So today is the last day of 11.2, and this part isn't really in your book, but it comes up a lot, especially on the SATs and other standardized tests, and that is contingency tables. So we're going to work through a couple of these together, and then you'll have a worksheet for homework. I put this file in the assignments, so you should download this file or print it first before taking the notes, so you can take the notes right on this. Okay. A group of 10th grade students responded to a survey that asked which math course they were currently enrolled in. The survey data were broken down as shown in the table. So here's the table with female, male, Algebra 1, Geometry, Algebra 2. They got totals. It's all filled out. You can imagine, though, if a couple of these numbers were missing, you could probably still fill out some of the numbers. Okay. What is the probability of being a female who studies geometry? So unless they tell you specifically that it's out of a different group, you can assume that it's out of the total of 310. And in this problem, that is the case. So how many females are taking geometry? 53. And how many people are their total? 310. And that's it. That's the probability of being a female who studies geometry. 53 over 310, which turns out to be 17.1%. Okay. Similar problem. What is the probability of being a male who studies Algebra 1? So the males who study Algebra 1 are right here, 44. And so the probability of being a male in Algebra 1 is 44 over 310, which is 14.2%. Not so bad, right? Okay, so now we're going to look at part C. This one's a little bit different. If a student is a randomly chosen male, what is the probability he studies Algebra 2? So this is an example of they've changed the total. So instead of using the total people, they've sort of restricted you to only looking at a total of males. The females are not considered in this problem at all. So if we just have a group of males and we choose one, what's the chance that he's going to be in Algebra 2? So in that case, it'll be 57 over 160 instead of over 310. Okay, so you just have to, you have to be careful of the words, but I mean, that's true for all of this probability stuff. Okay, let's move on. The table represents the 50 movies that had the greatest ticket sales in 2012, categorized by movie type and Motion Picture Association of America rating. Okay. What proportion of the movies are comedies that earn a PG-13 rating? Okay. So, to me, this just sounds like it's out of the total. So I'm going to go and I'm going to find the comedies that are PG. So that's 4. And then my probability is going to be 4 out of 50. Which is 8%. Okay. What proportion of the movies are dramas that earn an R rating? So dramas of R, oops, wrong tool. Dramas that are rated R is 6. So that would be 6 out of 50. Or 12%. If a randomly chosen movie is an action movie, so this is similar to the males problem up above. They're limiting you to only action movies here. So out of just action movies, what is the probability that it's PG-13? So that's going to be 10 out of 18 because 18 is the total number of action movies. And that's 55.6. Okay, is that working for you guys? Okay. The table shows the distribution of age and gender for 25 people who entered a contest. If the contest winner will be selected at random, what is the probability that the winner will be either a female under 40 or a male 40 or older? Okay, so let's break this down. We have females under 40 and we have males over 40. So let's get those numbers off the table. Females under 40, that's 8. Males over 40, that's 2. If you want the probability using OR, most times you can just add the numbers together and then divide by the total. Sometimes you can't, and I think that might come up in the next section, but I didn't get that far yet, so you're going to have to bear with me. But the probability of being a female under 40 or male over 40 is going to be 8 plus 2 out of 25, or 10 out of 25, which is 40%. Okay. This example is going to take a little bit more time, and we're going to use a Venn diagram to help us illustrate this. So a Venn diagram, that's the thing with the circles that overlap. Okay. A survey of 120 college students found that 76 live in a campus residence hall, 89 participate in a campus meal program, and 52 do both. Draw a Venn diagram illustrating this. Okay, this is one of those, sometimes it sounds easier to do than it is. This is not doing what I wanted to do, but that's fine. Ha, it did it. Yay. Okay. So this is going to be my Venn diagram here. Purple. Oops. Nope. Still doesn't. What the heck? All right, hold on. I'm getting it. I want this, and I want... Nope, I want this. There we go. I got it. Okay, copy. Maybe it'll let me paste. Anytime now. How about paste? Ha! Got it. Okay. Sorry, took me a minute. It's so pretty. Okay. So the blue box here represents the 120 kids that were surveyed. We're going to call this box the dorm box, the kids who live in a campus residence hall. And over here, we're going to call this the meals. Those are the kids who have a meal plan. Of course, where they overlap is going to be the kids that do both. And then out here, we're just going to call this college students who were surveyed. Okay. Okay, so this sometimes can be trickier than you think it is. So the number of kids who do both live in a dorm and get a meal plan is 52. So that part is pretty indisputable. 52 kids go here. But now I want you to think about these other numbers. 76 live in a campus residence hall, but 52 of them do both. So you need to subtract 76 minus 52 to get out the kids who just live in a dorm but don't use the meal plan. Okay, so we're going to do dorm only equals 76 minus 52 is 24. So that's how many kids live in the dorm but don't get a meal plan. Likewise, if it's a meal only, you know, if they have the meal plan but they don't live on campus, so all of the people who get a meal plan who were surveyed, that was 89. but 52 of them live in a dorm. So the kids who have the meal plan but don't live in the dorm is 37. Okay. If you add these three numbers up, you actually only get 113. But how many people were surveyed? 120. So 7 of these kids are sort of out here in no man's land doing neither. They don't live in the dorm and they don't have a meal plan. They're just grown-ups living their lives going to college. Okay, so that can be tricky if you're not paying attention, right? Because if you just take the 76 and the 89 and the 52 and add them up, you're going to be way over the 120. So that can't be it. I mean, you can't have more than the total, right? I like to sort that out first before I go and look at the probability questions because, frankly, I can't even handle them until I get all these numbers sorted out. So let's find these probabilities now. Find the probability that a randomly chosen college student lives in a residence hall or has a meal program. So that's basically everybody except for these 7 kids. I just erased that. Let me put that back. So everybody except the 7 kids, that's 113 over 120, which is 94.2%. So that's the 24 kids who live in the dorm and don't get a meal plan, the 37 kids who get a meal plan but don't live in the dorm, and the 52 kids who do both. Okay. The probability that a randomly chosen student neither is in a dorm nor gets the meal plan, those are those 7 kids who are living in the rectangle and not in the circle. Okay. What's the probability that a person lives in the dorm but doesn't have a meal plan? Well, that's the 24 kids. And finally, what is the probability of having the meal program but you don't live in the dorm? And that's the 37. So these questions are sort of prompting you to appropriately fill out the Venn diagram. But we just did that before we even looked at the questions. I really can't even handle the questions until I know the numbers are all distributed correctly in their little spaces. But there are also different ways that you could be asked questions, from a situation like this, similar to the contingency tables. So all of these questions were out of the total, but they didn't have to do that. They could have said, what percentage or what's the probability of a student not having a meal plan if they live in the dorms. So that would be 24 over 76, because 76 is just the kids who don't, it's just the kids who live in the dorm. So, that's an example of how they can sort of change the questions up on you. But I think that is what the next section is, if I'm not mistaken. I think it takes into those account, like things that are happening at the same time. So with that, this video is over, and you should download the worksheet that's on the assignment section of Teams and do that for homework, and then submit it along with this for your notes so I know you watched the video. And that's all for today.